Welcome back to my Unreal Engine 5 Tetris-Like tutorial. Today we are going to work on the setting the collision to static and ending, updating the status of the player board once the drop is finished. So the first thing I had it to add was this set collision to static to block base. And here's what that looks like. Basically, I'm just taking the block collision, set collision object type, and so I was changing it to world static, so it will still interact with the new tetraminnows coming in as we set up the collision to the active tetraminnows to be different but to interact with world static. And then the response to world dynamic is to overlap, and the response to world static is to ignore. So it shouldn't touch anything else that is world static. That will eventually come into play when we have the cube forming up above the player area. But right now, that's basically just kind of forward thinking. All right, I think that's everything that I did with the block base. Let me check my source control. I'm trying a different format where I make the change first and then use source control as a guide. Whereas my last couple of tutorials have all just been, just kind of like me moving the code over as I do it. But all right, yeah, I think that's everything for block base. All right, so now let's move on to tetraminnow base. Look here. So yeah, in tetraminnow base, I added this set collision to static, which is basically just a pass through to the block itself. Why aren't you letting me? There we go. Why did it go to that one? I clicked the wrong thing. Want tetraminnow base. There we go. Yeah, so all this is doing is looping through the blocks in the tetraminnow, setting them each to static, and then returning the blocks. And that's pretty much it for this one. Let me double check that real quick. Yeah, I think that does it for base. Had some on-screen debug messages, but I removed those. All right, so then that brings us over to the player board itself. So I have a drop-ended function here. Some of the old logic had to do with changing the active slice, but we'll get to that later. Really, all I want to do is get the blocks in play appended to the, get the tetraminnows in plays blocks appended to blocks in play so that it'll stay part of the board even after we destroy the tetraminnow in play itself. That is why in set collision to static, I'm actually returning all the blocks so that I can add them here. And then this is important as well to set the tetraminnow in play to a null pointer, because if you don't, it still has the address in memory of where it used to be. And the logic that I have to pop one off the queue only triggers if this is a null pointer. So even though you destroy it, you still got to set it to null pointer, at least for the way I set this up. I found that to be like the easiest way to know that a new tetraminnow is ready. Although in retrospect, once I set up these e-board statuses, I could probably pop one off when the board status is free. Yeah, so this is what you get when you have like multiple iterations of code and refactoring and stuff. But the null pointer is working just fine. I could probably just as easily use EBS free here. But yeah, I won't worry about it for now. All right, so let me check over here, make sure that there's nothing else. Oh yeah, and then up in tick, I needed to start putting my if statements in here. So now that we have the board status, we're going to start actually using them. So if the drop is finished, that's how we know to go to drop ended, and that's how we know to add it. And then down here in the status picker, I think all this was here before, but I basically just set it up to have some on-screen debug messages, and um, this is how it gets set back to free. After the drop is finished, Tetra minimum play will be a null pointer, so it'll fall through both of these, and then it will end on EBS free, which will allow the code to pick it up here, where we check set in play. This is where we pop off a queue, and then we're back into the stuff that we already did. All right, so let's do a little testing. We didn't set up rotation yet, but we'll do that probably in the next video. Actually, we still have time, and I could probably do that in this video. Let's play test this. I don't think I changed anything since I last play tested it, so it should go without a hitch. Yep, yeah, so we still don't have any rotation, but you can see the status is changing up here. Go from free, dropping to drop finished. Then we can pop one off. Perfect. All right, well, I'm going to move on to rotation. That shouldn't take me too long, so I'll cover that in this video as well. I'll be back in a moment. Okay, welcome back. So I just finished the auto rotate, but before I forget, I wanted to bring something to attention. I'm removing this EBS moving status because I never actually use it. I think I just assumed I would use it, but I didn't. So this was in tetracube.h, and then in player board CPP, I also had, this is where I was setting the status, but it wasn't being used anywhere. So I'm just completely getting rid of it. All right, so the next thing I did was I created a couple new functions. So the first one is to normalize the rotation. This, all it's doing is taking the orientation. If it gets greater than 3, it sets it back to 0, or if it gets less than 0, it sets it back to 3. Which sets us up for the rotate clockwise and rotate counterclockwise, which are all they're doing is adding 1 to the orientation or subtracting 1. Then I'm immediately calling normalize rotation and then set block positions, because if you don't call set block positions, it's not actually going to show up on the screen or do any collision checks or anything like that. But the real meat is in the find best rotation area. So the first thing I'm doing is I'm grabbing an average distance to the input. You'll know more about that in a moment, but I'm just defaulting it to -1. And the best average distance to the input, I'm just defaulting it to 10,000. And then some variables to just hold the previous best orientation and the best orientation. So this is kind of a brute force solution. Basically all I'm doing is I'm looping 4 times because that's how many orientations there are. I rotate it clockwise. I just arbitrarily picked that. I haven't tested it with rotate counterclockwise. In fact, I don't even use rotate counterclockwise yet. I might eventually make some manual or like controller based controls, and then it'll be nice to have a button or something that rotates counterclockwise, and then the other one will be rotate clockwise like it is in normal Tetris. But anyways, that's why that's there, even though I'm not using it. So we're rotating clockwise. We're checking if it is not colliding. We're calculating the average distance to the input. And that average distance is basically just taking the distance from each block to the input location. Input lock or input location is something we set up in a previous video, but this is why, so I didn't have to like pass it in or anything like that. The Tetraminnow just knows where it is. So I'm basically just adding up all four blocks, 0, 1, 2, 3, getting the distance to the input location, and then dividing it by 4. That's all there is to it, just a regular average. So if the previous average distance to the input is less than the current best, then we're swapping them out and then setting the new best orientation to the current orientation. Now, the reason I'm doing it this way, and if this doesn't make sense or anything, essentially what I'm trying to do is get all four blocks as close to the input location as possible. So that's why we're getting the average distance, because if there's an orientation and one of the blocks can like slip in a little bit closer, then that means the average distance overall is going to decrease, which means it's ideal for what the user is probably trying to get. So if we get to here and the best average distance is still 10,000, that means we're just like inside a wall or something. So we set the orientation back to the previous best and then reset the block positions. But if it's not still 10,000, it means that we found a new rotation that is better. So we're setting the current orientation to whatever the best is, and then setting the block positions. So it's all set then. Yeah, I think that covers all of that. Let me go back to my source control and make sure there isn't anything I forgot. Indeed, there was something I forgot. So move function. I had to uncomment all this stuff. Now we're actually finding the best rotation. Whereas there were comments here as well, commenting this out. So for move left, right, up, and down, I uncommented out this if-else statement from previous. And I think that actually covers everything now. So yeah, the 4 new functions, uncommenting those find best rotations, moved the moving status. And all right, so there was one other thing I did, but that was actually in the editor. So I'm going to open that up. I'll show you how this is working, and then we can call it a day. All right, so the only thing I did in the editor that I wanted to bring attention to was I added this post-processing volume. You just have to go up here, maybe, yeah, there it is, volumes, and then post-processing volume. Now, the other thing I did was I searched for infinite extent unbound, so it takes into account the entire level. And then from there, you can set it up however you want. This is for all your post-processing needs. There's tons of options here. But the main thing is I kind of wanted to turn on ray tracing because the reflections aren't like, you know, fantastic in this. But I just set it to brute force since this is a pretty easy game. Max bounces to 1 and then samples per pixel 4, and that's the only thing I changed. Now, is there a motion blur? Yeah, motion blur is off. Fantastic. But this also reminds me, I wanted to make these shiny. So float, or no, it is const. And then roughness. Oh, hit escape. Shift D, I believe. Is it Alt D? It's just D. The hell do you duplicate? One moment. I need to remember this hotkey. Okay, it was Control D. So roughness. Things shiny and metally. Don't need the emissive, don't need normals. Alright, now that we made the graphics pretty. Oh, okay, maybe the metallic is too much. 25? Can't say I'm liking the metallic at all. All right, but the actual rotation is working, so mission success. Let's pop out, look at our beautiful ray tracing there. Get some reflections in the... Yeah, it's not bad. But it had some like weird pop in for a second there, and it... Yeah, the lack of bounces looks like it loses some resolution as it gets farther away. It's kind of cool. See what it looks like without it. So pop out. It was a little fuzzy, but that's about it. Honestly, I mean, I wasn't getting any performance hits. I was just kind of curious what it would look like. Um, but yeah, it's not really doing a whole lot, if you ask me. But yeah, so enough of that playing around. I'm going to end this video here. I hope you enjoyed it. I'll see you in the next one.